Welcome to ClueCon Weekly. Join us every Wednesday to learn about the latest cutting-edge developments in the real-time communications industry. ClueCon Weekly is brought to you by FreeSWITCH Solutions. Get support and professional services directly from the creators of the FreeSWITCH open source project, solving your issues in the most efficient, stable, and scalable way possible. Get the FreeSWITCH advantage. Visit freeswitch.com. Also brought to you by ClueCon, the premier technology conference for developers by developers. Join us every summer in Chicago. ClueCon kicks off on Monday with our annual hackathon, The Coder Games, followed by 3 days of technology-rich presentations discussing telecom, WebRTC, and IoT from developers around the world. To learn more, visit ClueCon.com or call 877-74-CLUE.
All right, everybody, welcome to ClueCon Weekly. Today is the 12th of September, 2018. This week, we're going to be joined by Chad Phillips. For you guys that don't know Chad, he's been around the community for a long time, and he's also done a lot of work in various things that are FreeSWITCH related. One of his most recent projects involves a lot of WebRTC work. So he's going to be talking about some of the problems that he's encountered with the different browsers, how to work around those, and some of the other cool stuff that he's been working on. So stand by for that. First, let's go over to see Miss Abby and for the news. Miss Abby, how are you doing today?
I'm doing great. Thanks for asking. Hi, everybody, and thank you for joining us today on ClueCon Weekly. As always, if you have any questions during this call, please comment them in the YouTube, HipChat, or IRC channels, and we will do our best to answer them live during this call. So a lot of things are happening in the FreeSWITCH world. If you haven't already heard, the FreeSWITCH 1.8 public release is out, and we also have a lot of new content coming up, especially on our YouTube channel. We have not one, but 2 new FreeSWITCH with Fred videos, so make sure you go and check that out. Also, make sure to stay updated with our FreeSWITCH blog by checking in on our website or following us on our Twitter and Facebook pages. So tomorrow, FreeSWITCH has virtual training available at 9 a.m. So if you're interested in signing up for that, then you can email Sharon at freeswitch.com to get a space in our training tomorrow. So ClueCon was a little bit early this year, but next year everything's back to normal. We're going to be having ClueCon from August 5th to the 8th. So everybody mark your calendars. And if you are traveling overseas to come visit us in Chicago, Illinois, make sure to get a head start on your visas. You can email Sharon at freeswitch.com for that as well. If you can't wait until ClueCon to see us, then you can visit us at AstraCon. FreeSWITCH is going to AstraCon this year. Anthony Minisali is going to be speaking. We're going to be having a lot of fun in the hotel pool, so come visit us at AstraCon. As usual, follow us on all of our social media, subscribe to our YouTube channel, and sign up for our newsletter to get even more exciting news from the FreeSWITCH team. All right, thank you guys for watching. Back to you, Ken.
All right, thank you very much, Miss Abby. So we're going to jump over to Jersey Mike here. I think you've got Mr. Jarris joining us for Community Corner this week. Hey, guys, how are y'all doing?
Doing great.
I want to thank everyone for joining us today, and we have a question for Mike. Awesome. And that question comes from the FreeSWITCH users mailing list. It says, the question is from Sukitha, and it's, Dear all, I installed FreeSWITCH 1.8.1 on Debian 9 using apt commands. It seems like the package has built without Postgres support. When I run the application with the Postgres configuration, it gives the below error. PGSQL not available. Is there any special reason to remove this from pre-built packages? Is there any way to enable Postgres support without rebuild? So, Michael, this is quite a simple one, right?
Yeah, go for it. We did have an issue on Debian 9. There's some issues with OpenSSL and having multiple versions of OpenSSL that have given us quite some problems. And we ran into an issue when Debian decided to change the version of OpenSSL that libpq, the Postgres support library, was linked against after they released it. So I did have to temporarily disable it, and it did slip into the 1.8.1 release. It is now fixed in master and in our repositories. We have an override package for libpq for stretch. And the current master unstable packages do have this fix in it. There's two ways that you can fix this. You could rebuild 1.8.1 with the support enabled, or you can wait for 1.8.2, or you can just use the unstable packages until 1.8.2 is available, which is coming up pretty soon, trying to get a few more patches into 1.8.2, but we're getting real close on that in the next week or so.
Okay, well, thank you, Mike. Answers from the experts. And back to you, Ken.
Back to me. Let's just jump in and get Chad in here.
Okay, so Chad's joining us today, and he's going to be talking about RTC. So, Chad, let's hear it.
Around how to make, was I muted? Sorry about that. So I'll try again. So I'm going to be talking about WebRTC today, and the bulk of the knowledge I have to communicate is really around how to make WebRTC work with the newer implementation released in Safari and on iOS specifically. There's a lot of corner cases. But before we get into that, I thought it might be helpful to just provide some context about WebRTC in general. So the flow is going to kind of be, I'll talk a little bit about what WebRTC is, why you would care. I'll show you quick at working on iOS, and then we'll kind of move into sort of like, just general interoperability stuff, and then at the end it'll be a lot of like kind of specific problems I ran into on Safari and iOS, and I can show you guys some code examples there to hopefully clear things up. So the goal at the end of this is that if you are a current WebRTC developer and you're going to try to implement on iOS, it's going to save you a lot of headaches. That's basically the goal. Sound good?
That's very important knowledge, that's for sure. So
agreed.
It's always good to get that out to the community.
Excellent. Okay, so video is freezing up a bit on my end, but hopefully you guys can still hear me. I'm just going to go ahead unless I hear otherwise. So first thing is like to look at the big picture. So what is WebRTC? And WebRTC is both a specification and a set of open source components that allow browsers and mobile applications to communicate using real-time media with a set of really simple APIs. So that's kind of the what it is. Now the why question was pretty important to me. As I was preparing for this talk, the reason why it was good for me is because I'm a developer. I wanted to be able to crank out a video conferencing application, and this was just very low-hanging fruit. I was able to do it way easier than if I had tried to write one from scratch in C or something. So that's certainly one of the things that happens is WebRTC, it gives people the opportunity to level the playing field around real-time media, both on the developer side, because I really experienced that, how much easier it was to work in JavaScript APIs than it was to, say, write FreeSWITCH. But also on the user side, the hope of WebRTC is that when you have a great degree of platform interoperability, then it's also very easy for users to use real-time media. They can just be in a experience in a browser, click a button, and bam, they're talking with somebody, or they're getting data transfers or whatever. So that really is, I think, the thing that feels the most exciting to me about WebRTC, and the thing that was kind of the aha moment as I was thinking about why it would be really cool to why it's so why it can be so game-changing is because previously, when you do real-time media, you were usually in some kind of a walled garden scenario. You were on Skype, for example. It was sort of like the very first big one. And now there's this opportunity to take all of that real-time media capability and put it in any context quite easily so that users can access it and so that developers can access it. And
right.
I remember...
And so if you really think about it, just the base concept of being able to just handle it within a device or within a browser without installing an entire software package like Skype, I mean, you would think that nobody would ever go back to that.
Right. So there's the ease of use for sure. But I think the part that really got me, because I've kind of understood that, and the ease of use piece, as we'll see as I talk a little bit later, is sort of still not quite, it's a bit of a dream that hasn't quite been realized. We're kind of getting there. But the other piece I think is really exciting is how it removes the walled garden and puts it so that you can use real-time media in almost any circumstance. So say, for example, the first time I tried Asterisk back, I don't know, 2007 or 2008, I had this moment where I was like, oh my God, I've got a phone call in a computer. I can do anything with it. Like now, like I have all this flexibility. And so I think that's the same thing that WebRTC makes possible, is that once you get this real-time media into a context like a browser experience, you can put all kinds of crazy stuff with it. So there's probably all kinds of things that are going to be created in the coming years once once the standards stabilize that we've never even thought to use before in terms of combining real-time media with other experiences. So I think that's pretty.
I think
exciting.
when you look at the adoption rate of how quickly, it started out a little slow, right? Because it just didn't work, right?
Yes.
but then it skyrocketed. And I remember hearing these statistics that I think between Facebook and Google, there was billions of minutes that were exchanged, and it went from hundreds of millions to billions in just a year. And
right.
That type of growth, that's like hockey puck growth. You don't see that. You don't see these drastic changes that frequently.
And I think that's because everybody sees the potential, but the limitation has been a lot of the interoperability problems, which I think transitions pretty good into another short piece I'd love to talk over, which is just a very brief timeline of how WebRTC evolved. So maybe you can begin to see from the timeline how it went from it's a promise, and all of a sudden it kind of cracks open. So the whole thing, and I wasn't around until about 2015, but I do have a basic understanding of the big pieces of history. So in 2010, Google purchased a few companies. One was called Onto. They had the the VPX codecs, which of course is one of the major video codecs that you're using in WebRTC. So they bought Onto, and they bought another company called Global IP Solutions. And that company had figured out a lot of the framework, it's kind of simplifying real-time media. They had frameworks built for that. So Google bought them. They ripped out some of the
great things they did there is because, it wasn't originally open source, and what they did was they turned it around and open sourced it.
Right. I think they took out some proprietary codecs and then just open sourced everything. So that was step one, was just getting the tools. Google kind of leveraged getting the tools that were necessary to make WebRTC possible into the public domain, which was a pretty big step. And then that was in 2010. In 2011, they actually took those tools and implemented them and released the first official version of WebRTC. And concurrently that same year, the W3C started writing the spec. Because remember, as I said in the beginning, there's a spec, which means you're writing this thing that all of the browsers and applications are supposed to agree, this is how WebRTC will work. And then there's the actual set of components that you leverage to make it easy for developers to be able to use WebRTC. So they're kind of, they've been moving concurrently throughout these years. So in 2011, it really kicked off on both sides.
And the hope is that people will actually.
I think there was a big crossing of the fingers. I think some of the big companies got in right away. Google, Firefox, Opera were all pretty early adopters, but Microsoft and Apple were sort of sitting on their hands. I have no idea why, probably just waiting to see what would happen. In 2013, there was the first interop where Firefox and Chrome were able to actually talk to each other, which was a big step. It was the first moment where you realize, interop can happen if we can just get everybody on board. And then there was also the Android stuff came online at that point too. So I think probably all three, Opera, Firefox, and Chrome, had Android applications 2013, 2014. So now you're starting to see some of the major browser vendors are coming online. It's working in a browser and on the mobile application. So you're seeing the convergence of the interoperability dream, basically, right? And then in 2015, that was when Microsoft released kind of basic support. It kind of worked if you combined it with some other software called Adapter.js, you could make it work and interop with the other browsers. And then in 2017, we basically closed the major loop, which was Microsoft completing their implementation according to the specifications. And then Apple finally releasing something in 2017 according to the specifications, and the specification itself reaching maturity. The 1.0 specification has reached feature completion. So that was this last year was the year where everything was finally okay, we've got all the major people on board, we've got the spec so that they know how to write it so that we can be consistent. So that's basically how the evolution worked in major pieces. Now, it sounds like
when you talk about this evolution, what's the easiest way to sum it all up? Now we're ready to really start using the
Well,
technology, right?
I think the easiest way to sum it up is there is agreement and participation of both the specification and the implementation from all the big players. Now, that doesn't mean that reality matches up with that yet, which I think is probably a good thing to talk about. So it's like, yay, 2017, we did it. Everybody's agreed. We have the spec, and everybody's going to write to the spec. But there's still issues. Like we're still trying to like stabilize all of that. So as an example,
so it's not a perfect world.
It's
right?
not a perfect world yet. It's far, far better. I mean, I really do think that you can say you have basic interoperability, but I'll talk about a couple of the difficulties here. So one of them is that, yes, we have this spec that everybody is if they all write to the same spec, then the interoperability should work. But there are variations in how the people are implementing it, and then there's some stuff that just hasn't been implemented. Like a major piece that a browser vendor just like, well, we haven't gotten to that yet, or maybe they don't want to support it or whatever. One of the examples is let's say you want to only send audio or video. So normally when you set up a peer connection, you're going to want to send and receive. Like in this moment, I'm talking to you, you're getting it, and I'm getting it back from you. So I'm both sending audio and video and receiving it. But there might be circumstances where you want to only send your audio or send your video. So in that circumstance, there's a certain way to do it in the APIs, but they're implemented differently across certain browser vendors. So there's no consistent way to do it. You kind of have to say, if Safari, do this thing, if Chrome, do that thing, which is kind of messy, right?
You know, and I think where a lot of this kind of comes into is security too. Mm-hmm. So a lot of the browser manufacturers, in the end, they're completely paranoid about security, and we see how each one of these different vendors actually how they implement it, and they've all implemented it a little bit different.
Yes, and there are definitely, when we get into the nitty gritty, I'll definitely point to some of the stuff, especially in Safari, that I ran into that was, from their perspective, security related, and from my perspective as a developer, maddening to be able to try to get it to work. So since we're talking about some of the difficulties with Safari, let me just say with these sort of interop difficulties, some of the other big pieces that are missing in terms of Safari specifically is that there's Safari. Now, remember back when I said Google purchased the On2 and open source to VP8? Well, that's a video codec, and so is H.264. And those are supposed to be, according to the specification that I had mentioned, always implemented in any WebRTC. When a vendor, builds a WebRTC implementation, those are supposed to be supported. Well, Apple just decided we're not going to support VP8. And they didn't even not build it. They literally turned it off. Like the library that they're using has support for VP8, and they're just like, no, we're not going to do that now. And we could speculate as to why, but that's just the reality, is that there's no VP8 support. And that really is one of the things that hurts the interoperability situation, which I can talk about a little later. So there's that. There's the fact that Apple was the last of the table for whatever reason, and their implementation is new. WebRTC is a very complicated stack, and so there's still there's things missing. There's bugs that are, it was the entire sending audio was broken for most of their beta release for iOS 12, things like that. It's just, they're still kind of getting their feet with the implementation.
Why do you think Apple was the last to the table to implement all this stuff? Is it because they have like their own proprietary stuff that they really wanted to have? Like you go back to some of those old wars that they've had with technology and stuff. And so is this more of that?
Well, I have two guesses. First of all, part of the challenge with Apple is they're very secretive, which means that anything I say is going to be a guess. And as an example of that, how they're handling WebRTC is similar to that, which is they released it, they barely wrote anything about it. There was one major post that the WebKit team did to be able to kind of say, here's the basic way how to use it. But they haven't written anything else about it. There's no intent. We have no idea if they intend to fully support the spec. We have no idea what their future development plans are. Submitting a bug to Apple is a nightmare because you basically you just sort of throw it over the wall and they're like, okay, and you never hear back. It's just really hard to deal with them as a user and a developer when you want to try to get information if they're not giving it out, right? So that opaqueness makes it very difficult. So my guess is for why they didn't include VP8 support are, one, yes, they were trying to be the gorilla in the room, controlling, what they wanted to use is one. But there was a more practical reason too, and I would say this could apply to all devices, and I might be wrong here, so somebody correct me in the chat if I am, but a lot of the mobile devices have what's called hardware acceleration for the H.264 codec. And my guess is Apple was being very protective about burning out their users' batteries by supporting a codec that didn't have hardware acceleration, because when you decode that with a chip instead of having the CPU do it, you're going to burn through a whole lot less battery. The CPU is going to be available for other stuff. So it's one of those or both of those things is my guess, but we may never know because they just, they won't say anything about it. So
that's interesting, though.
Yeah.
Only time will tell, right?
Right. And I mean, I've got my fingers crossed. It took me 3 months or so of a lot of what I'm going to talk about later is just stuff that I had to beat my head off of for hours or days to get it to work. But it took me about 3 months to get my iOS devices working with my video conferencing platform. And I'm crossing my fingers please, Apple, continue to at least basically support what you've done. Don't eject it like you did with Flash. Fix bugs when they come up. So it's a bet, right? And it's something for people to think about. If you're going to use WebRTC on mobile, it's a very important consideration. Do you want to try to do it in the browser like I did, or do you want to try to do it in a native app? And in the native app, you have more control, but the curve, the learning curve, and the development curve is a lot longer. It would have taken me 1.5 years to do a mobile app by myself. I did this integration in about, like I said, 2 to maybe 3 months.
So you mean something like Cordova or something like that, similar?
Yeah, there's React Native has a plugin, and then you can use there's also a plugin that works. I can't remember the name of it, but basically you can make it work with. There's a WebRTC plugin that you can use for say iOS and Android, and there's also a React Native. So you can kind of make all that work together. It's not impossible. I've heard. Jitsi Meet, I think, used that approach, and they have a native app that works on their SFU. But I think for me, with the learning curve, it would have been really long because I don't know any of those technologies yet. So I just tried to do it, the straight ahead way. And it's a good test case. Somebody should try to do it. They say they support it, right? And now I at least have a path, and I can share this path for other people that want to try the same path.
Yeah, I played around with the Jitsi mobile app. That actually, it works pretty cool.
Yeah,
it works
pretty well. It works great. It does. It's another app you have to install. If we're talking about this user transparency type of thing, the thing I've implemented, if you're using Safari on iOS, it just works, minus the bugs that I have to work around. So
let's hear about those workarounds.
Yeah. So Ken, can you toss up the screen share for me? I'm just going to show a couple quick demos of it. Yes, it actually does work on iOS. So I'm not savvy enough, didn't figure out how to do it live. So these are screen captures I did this morning on an iPad mini running on my platform that I built. So the first example video is just a connectivity test. So you'll see, I'm accepting the permissions, and then there's a camera selection step right there. And then it's going to actually connect one to FreeSWITCH and also to an SFU I use called Janus. And you'll see it sending the audio and video data is transmitting. And you see video from both the MCU of FreeSWITCH and the SFU of Janus right there. So that was just a basic connectivity test that I wrote. And then just to sort of see the thing in action in the actual platform that I built. This is, again, on the same iPad mini this morning. So it's going to grab the camera access. It's going to load up the video. Here, this is in FreeSWITCH. I'm just on my iPad mini and another device in Chrome. And then I'm opening up the access to the SFU right there. And then entering the SFU here. And you'll see that's still video, but using a totally different stack right there. And then in this next shot, you'll see that it splits. This is sort of like the people moving from the SFU back to the main room. So I've got both of them running at the same time in my application right here. And then at the very end, it turns off the SFU and moves you back into the main room. So I wanted to show that piece because that's an illustration that you can do. You can turn me off there on the screen share, Ken, for now. That's an illustration that you can do some fairly complicated stuff in iOS. But it's not easy. I would say, like, if you're going to use this stack on iOS for something simple like just like a one-to-one audio-video call, it's actually not that hard. And I'll talk about some of the basic things you need to be aware of in order to accomplish that. But when you try to do more complicated things like what I just showed you, you're going to run into you could run into a bunch of difficult edge cases. And so the hope is, if we have enough time.
Let me ask you this. Earlier, you mentioned adapter.js, right?
Yes.
So wouldn't these be, use cases where adapter should just, essentially adapt, right?
Well, that's a wonderful thought, and that's the dream of adapter.js. And what I can tell you from my experience is, again, when you get into these more complicated things, adapter just can't handle everything. So as an example, that API difference I said, when you're just sending audio or video, adapter can't handle that between Safari and Chrome. If you try to use one API iteration, say use the Chrome one, it won't work on Safari, and vice versa. They're not converged enough, and adapter can't handle it. So I use adapter.js because it does smooth out some of the rough edges, but I think it's important to know that it's not a cure-all. You don't just put adapter.js in and it magically fixes everything. It might, if you're lucky. You get what I'm saying? But it may not either. So my suggestion, and this is, I have a couple of suggestions. One is just general suggestions when you're developing for WebRTC right now, and then specifically for iOS. One is, you really want to use the current WebRT specification. I'll put a link in. Let's see. There's a link I found that was that's not the right one. I'm not going to have that one. At any rate, there's different iterations of the spec. So when I said the spec started in 2011 and then it was finalized in 2017, they were kind of discovering how best to implement it, right? In terms of how do we want to structure this as far as an API, and they went through, I think it was 3 different iterations of how to handle tracks and streams and media. And so that's one of the things that adapter.js does, is that it's like, all right, which version of this crazy evolution are you using? We'll try to morph it into the newest version. And it can do it pretty good, but maybe not get everything, like I had said. So my recommendation is, if you're starting a new WebRTC app, you really want to try to use the newest spec. And there are places you can go, like the Mozilla Developer Network documentation for that, or the WebRTC project has a samples repository that they do a really good job of keeping current with writing their samples about how to do all these kind of different things with WebRTC, send data, audio, video, adjust, switch cameras, all that kind of stuff. And their samples are almost always written against the latest spec. So those are 2 really good resources, the Mozilla Developer Network documentation and the WebRTC project's samples repository. But writing against the latest spec is going to save you headaches because it's stable now, and it's going to be easier to fix things going backwards. If you have an existing app, adapter might do it for you. My recommendation is still to try to convert things to the newest spec when you can, because it's not all that hard, actually, in most cases. So that's for general, write against the latest spec. Specifically, if you're going to try to get it to work on iOS, my recommendation is you want to test it on both major kinds of devices, because there are some differences in how they handle resources, specifically video. So if you can get your hands on an iPhone and an iPad to do your testing, totally recommend that. And probably I would recommend starting on an iPhone first, because it does seem to have more restrictive limitations around how it uses resources. So if you can get it to work on your app to work on iPhone, it's probably going to just work on an iPad. So those are sort of just, I would say, my general suggestions for development moving forward with WebRTC and iOS specifically.
So iPhones are very big on sandboxing, right?
Yes.
And so essentially each application is completely sandboxed. How does that affect things?
It's not, I don't claim to be an iOS expert, so I probably can't speak too intelligently about that. I mean, what I know is that your WebRTC application is going to run inside of Safari proper. It won't run inside of an in-app version of it or on any other browser, which I'll talk about in a little bit. So you get into the Safari climate, or you're inside the app, and within that app, then they expose the JavaScript APIs that you can use to be able to do things like connect, exchange media, local storage works there, so you can store, cookies and all that standard stuff. So I didn't have any need to get outside of that Safari environment and what the JavaScript APIs provided, so I can't really speak to more than that. But I mean, again, what you saw from the demo, like you can do quite a bit in there, as far as being able to mess with the media.
And then have you played around with stuff like call stats or test units and stuff like that?
I mean, a little bit, but not specifically with iOS. So yeah, I can't really give you too much there either. Most of my work was focused on, I built this really complex app that works amazingly on Chrome, and now I'd have to try to figure out how to get it to work on iOS. And it was just 3 months of just smash, fix one problem, do another. And hopefully, like if we have time, I'm not sure how much time we have left, but I've got some solutions for folks who might run into those same problems. So if you want, we can look at those. I can talk a little bit about those things. Okay, cool. Excellent. Ken, can you fire up that screen share for me again? We might need that right now. Okay, so just first, I would call just your initial steps. You're going to need to do these things no matter what you're doing, and even if it's the most simple app. So the first requirement is that iOS has a required plays inline attribute that you have to add to your video tags. So you can see on the screen there, the top is sort of the old way of doing it, where you just use autoplay and it would start playing. But if you want to get it to play on iOS automatically, you also have to add this plays inline tag that's on the lower section there. And I did also hear that Chrome is sort of starting to, that plays inline is, I believe, also part of the spec now for HTML5. I might be wrong about that, but I'm pretty sure that's right. And I had gotten some reports that Chrome is also starting to need that as well. So I have that attribute in all my video tags that are going to be WebRTC enabled now, and it works very well. That's a pretty simple change, but if you don't do that, especially on an iPhone, you're going to try to get your video going and you're just going to see a black screen. So that's the very first thing you want to make sure you get handled. And then once you've got that, the next major thing in terms of just every app developer is going to have to be aware of it is the rules for autoplay on iOS, or WebKit specifically. And so they're up there on the screen there. But the essence of it is if you get permission from the user to use their microphone camera, then you're going to be okay in terms of autoplay as long as you use that plays inline. The trouble you can run into is if you're trying to do some kind of a receive only situation where you want somebody to see something but you're not asking them to send anything, if you're not going through that step of getting the user's permission to use their media, then the autoplay rules won't work in some cases, and you'll need to actually start playing the video by having the user do some kind of a user action, which is pretty typical. It's pretty much in line with all this recent protection that's been added in browsers, where when you go to, say, a news site, it doesn't just start on a mobile device, it doesn't start just blaring a video and audio on you automatically. So those are really meant to be the same kind of protection in the WebRTC land, but they recognize that there's some special cases for WebRTC and to be able to work a little more smoothly, they loosened it a little bit. And the big loosening is if you get the person to accept they grant you microphone and camera permissions, then that sort of counts as your user interaction on that page, and they'll let the audio and video autoplay. So you do those two things, and your app is simple. Great, you're in good shape. You may not have any more problems. And then I wish you luck because it certainly wasn't that simple for me. And the rest of what I have here is going to be just the various things that I ran into, the various difficulties I ran into. So the first one, and actually now that I think about it, this next one is going to be one that everybody's going to run into, which is that when you try to run a WebRTC application on iOS in either any other browser than Safari, or even in the Safari's, I guess they call it an in-app browser. I guess that's like, I don't use that very much, but like say you're in Facebook and you click a link and it doesn't open up Safari, it just sort of opens it in some browser in the app. None of that's going to work. The WebRTC isn't going to work in that situation. And the reason is because there's a specific thing called WK WebView that the APIs aren't exposed to. I guess other browsers and the in-app stuff for Safari, it uses that WK WebView API, and Apple, again, don't know why, but for whatever reason, they haven't exposed the WebRTC APIs to that. So that equals If you go on iOS in Chrome, it won't work. If you go on Firefox, it won't work. If you go in Facebook and use the in-app browser, it won't work. But if you're in Safari proper, like you've opened Safari and you go, it will work.
What about Android?
Android doesn't suffer from any of that because they don't have those limitations. The WebRTC stuff, I mean, I don't know how many folks know this. I was pretty pained to hear it when I started along my road to doing this, is that all of the other browsers on iOS they're just basically WebKit wrapped in whatever visual wrapper. Under the hood, they're all using the WebKit logic. So Chrome isn't the same Chrome you get on Android or on your desktop, like compiled from, it's just a different, it's them leveraging Apple's walled garden of the WebKit stack with a Chrome topping, like a layer of Chrome on top of it. So that's why you run into this problem, is that's part of that security piece you were talking about earlier. They just won't let browser vendors compile their own stuff, their own engines on iOS, which is crazy to me, but that's how they have it right now.
That's interesting.
Yeah. So yeah, this is almost all the problems I'm going to talk about going forward are iOS specific, or specific to Safari on macOS and iOS. So yes, what I've done is just what you see on the screen there. I just detect if it's a non-Safari device, non-Safari browser, I'll just throw up an error message and say you can't do this. It's ugly, but there's really no other. There might be some fancy way to redirect it. I don't really know, but that was the low-hanging fruit for me, was just to say that you can't do it here, go to the other browser. I hope they fix that. It's been a lot of people ask for that feature. It seems like a no-brainer that they would just, because you'd still be using WebKit under the hood. They're just saying, yes, you can use the API for WebRTC under the hood. So hopefully they will. Next tricky thing. What you're looking at there is a simple, what's that place called? JS Fiddle that I wrote, that iterates common camera resolutions and tells you what's supported and not supported in a specific device and application combination. So this is Safari running on probably that same iPad mini. And what you can see is the only two resolutions that are supported are a 640 by 480, which is VGA, and 1280 by 720, which is, I can't remember what that's called. Is that 720p? Which is great. Is that what it is? Is it called 720p?
No, I think it's 1020. I think it's 1020. 1024 would be like 1K.
Okay.
Right?
Well, 640 by 40 is definitely VGA, and then whatever that's twice as big is. Those are the only two resolutions that are supported on iPad natively. So that's fine if you, again, this is a good example of, like, if you're doing a one-on-one call, that's great. You just grab one of those, send it, the other person sends theirs, and it looks fine. But if you're doing something like an SFU where you're trying to multi-party conference, 10 people together, you're going to very easily saturate somebody's download bandwidth unless they have a pretty big pipe with sending that kind of video resolution. So it's a problem. They don't provide a way to just say, hey, there are APIs in WebRTC that say, hey, send the video of this resolution. But that's up to the implementer, the person, the people implementing that stack to say if they're going to respect that or not. So say, for example, on Chrome, when you say, give me that top resolution, 160 by 120, which is an industry standard called QQVGA, it's really great for thumbnails. Like if you imagine you're in a Google Hangout, that standard layout where you have one big person and everybody else is on the thumbnails or whatever across the top or the bottom, those thumbnails are about QQVGA resolution. So it's really handy to have that resolution for those kind of scenarios, because you can send 10 of those and be using less total bandwidth than you would be sending one of the higher resolution ones.
Well, and you know what? I think it's also important to mention the differences between MCU and SFU in this scenario. Mm-hmm. So if you could touch on that.
Yeah, for sure. It's pretty simple, hopefully. I mean, the basic difference is that an MCU handles processing all the individual videos that are sent in and compositing them into one outbound video, whereas an SFU's only job is to act as a switching station to rebroadcast the stuff that they get into everybody else. So to make it really simple, you come to FreeSWITCH, which is an MCU. You send one audio and video stream up to the FreeSWITCH server. Everybody else is sending their individual ones. Let's say there's 10 people in the call. FreeSWITCH mixes all of those 10 people together and sends you back one audio and video stream to be able to see. Now, the disadvantage of that is that the server has to do an awful lot of work to do all that mixing. So you have to have a powerful server to be able to do a lot of video conferences like that. But the advantage is that the server handles all the heavy lifting, and it's only sending you back one audio video stream to decode. So that's really helpful on, say, something like a mobile device that really doesn't have a lot of CPU firepower. So that's MCU.
And bandwidth too.
And bandwidth, it can, depending upon how big of, that bandwidth, again, is largely dependent upon how big the video is you're sending back. If you're sending back a 1980 by 1020 video, that's going to suck up a lot more bandwidth than if you're sending back a VGA resolution, right? So, but it definitely can. It gives you the option to save a lot of bandwidth.
And the finite control of the stream
correct.
you're sending too.
Yes, and you definitely can get it so that people on mobile devices, their devices aren't going to blow up. Now, the SFU, let's take that same 10-person situation, and they're all sending their audio and video signals up to an SFU. What an SFU does is just it collects all those 10, and it rebroadcasts all those 10 to all 10 people, basically. And so you're in that situation, you're sending one stream up and getting 9 streams back because you're probably not going to get your own back. So now your device has to be able to decode video and audio for those 9 incoming streams. If those are all very large streams, it's going to bog down, especially if it's something like a mobile device. So does that basically cover, you think that covers the difference between the two pretty well?
Absolutely.
I guess the one other thing is to talk about the advantage. Like you might say, well, why would anybody use an SFU if it's harder? Well, why would you ever want to use that? Well, because when you get 9 individual streams back, you have a ton of creativity about how to use those. Like, for example, in my application, when people move into those breakouts that I showed you, let's say there's 8 people in there. I've put it in so you can drag and drop people and put any of the video feeds anywhere you want them. You can reorganize them how you want. You can overlay things quite easily. You can do all kinds of animations. And you don't have that kind of control over the video appearance and transitions in an MCU because you're just getting this one total already formatted video stream from an MCU. So that's one of the reasons, probably the biggest reason. And the other big reason is that you save a lot of CPU firepower. You can run a crap load of conferences on a server that's just rebroadcasting stuff, and using a little bandwidth versus having to mix everything and burn up CPU power. So those are the two big advantages.
So I believe earlier in the call you mentioned that you were using MCUs and SFUs.
Yeah, I do. I use MCU, anything bigger than 8 people, I'm using an MCU to mix them together. And in my app, I can do up to 32 people at one time. I can do more. I did a crazy test once where I had 61 people in a FreeSWITCH video conference, but it's insanity to look at that many people on the screen. So my application limit is 32 people at once. And that's running through FreeSWITCH. That means 32 people send their signals up to FreeSWITCH. It mixes it into one video canvas and sends it individual canvas back to everybody. And then when people move in from that larger group into the breakouts, the limit is 8 people. And that limit is because I want to be able for people running less powerful devices to not have their machine blow up. So I do use both. And I think now, if we want, we can talk about, I didn't really tell you how to solve this problem. I don't want to give you a problem, not tell you how to solve it. So Chrome actually lets you put any resolution that you want in there. And it'll downsample the camera resolution that comes in and send out the one, and give you the one that's the one you want. So you can just say, in the WebRTC APIs, give me 160 by 120, boom, you're done, send it, no problem. In this situation, you don't have that luxury. It literally isn't supported. iOS just answers back and says, yeah, sorry, I can't support that resolution, try again. So there's 2 ways you can work around this. I kind of chose the quick and dirty approach, which is I just got the VGA resolution and I cranked the bit rate way down. It's probably not as elegant as the second solution, but it did work. It saved on a lot of bandwidth, and the video quality still looks okay, especially because I am, the purpose of those is going to be to serve them in a smaller total resolution, or on the end users of the browser. So that's the sort of quick and dirty solution. The probably more robust solution would be to actually use some kind of trickery in the browser to put that video that you get, the VGA video, into some kind of a canvas and then downsample it, and then grab that smaller resolution from the canvas and put that into a stream and send it. I haven't tried that, but I've been told from people who know what they're talking about that it works. And it's more complicated, first of all, but the other thing is that it's going to burn some CPU cycles, because obviously the client is going to have to spend some CPU cycles resampling it from VGA to whatever other resolution that you want. So those would be the two approaches there to be able to handle that, that sort of bandwidth saturation problem. Okay, so we'll get into, this is a code example, which I'll talk about in a minute, but let me talk about the problem first. So you did mention about the security stuff, and this is another spot where the security on iOS, well, Safari actually, this applies to any Safari, not just iOS. Another place where the security stuff will bite you, and they have this idea that when the media device ID, so let's say when you request that you want to use a specific device. So if, say, for example, I have two cameras, one that's on my Mac and this independent one that I have is a USB one. So there are ways you can pick which video device, and the way you do that in WebRTC is you make a request for the devices, and it returns a list of device IDs, and then you say, oh, I want you to use this device ID when you send this video stream, which is great. It works quite well in something like, say, Chrome. You get that device ID, you can stuff that device ID in some kind of persistent storage and remember what the user picked. And the next time they come to your application, you just say, here's the device I want you to use, bam, and you're off and running. But on Safari, that doesn't work, because they have this concern about fingerprinting, which means that, if you have that data available, then people with malicious intent can take that device ID, that consistent device ID, and use it to sort of fingerprint your computer and be able to do nefarious things with it. So their solution to that problem is every single time you reload the page, it serves a fresh device ID, which works to solve their problem, but is a nightmare to be able to deal with when you want to try to consistently have be using the same camera. So the really only way to deal with that is that I found, and it's not, again, some of these solutions, they're working for me. They're not super elegant, but they do work. So in this particular situation, my suggestion is to store the device ID, and there's also a thing called a device label. Like when you loop over the devices, you'll get sort of a human readable label for the device and the machine device ID that you would need to pass to the WebRTC APIs. So to solve this, what I did was I store both. And then let me scroll down to the bottom, because I think that's where we're going to need to do the initial. Yes, okay. So, and I'll tie in another kind of trickery thing too. So there's one other thing about these device IDs that's worth knowing is that you don't get the list of actual devices until the user grants, it's a security thing, until the user grants permission to their camera and microphone, you're actually not going to get the quote unquote real list of devices that are available, and including the device IDs. So the very first thing you have to do if you want to get around all this is just make a get user media request to get in for both audio and video, and make sure that you get the user to agree to be able to use their devices. So that's what we're doing down here. You just pass audio and video true in the constraints, you issue a get user media request, and then in the handle success part, what I do is all I use that media for is just to get the permission. So then I'll go ahead and stop those tracks. And then after that, I call the enumerate devices API call, and that's the thing that lets you get all the media devices back. So once I've gotten that back, let me scroll up here.
And so we have a question from David, and he says, is there a way to have the peer connection reconnect a failed connection without going back through the user authorization of the media? And so what's really interesting is you actually answered that from the code right here, right?
Well, yeah, so Safari, or let me think about this. Yeah, so iOS specifically doesn't have any way to save the user's granting of the permission for microphone and camera. So anytime you reload the page, it's going to force you to re-ask for permissions, which is a real pain. On Safari on Mac OS, you can go in and say, hey, for this website, I grant it. So at that level, no, it doesn't really solve the problem. But as long as you're not talking about page reloads, the moment you get the person's microphone and camera permissions, you can do anything again in the background to be able to, hang up a call and try again, things like that. Does that answer the question?
I think so.
Okay.
David?
Cool. So where were we in the code example? Oh, yes. So once you have the devices, and you can see here, this is the callback that gets called, then it's pretty simple. You just loop through trying to match by ID first. And if you can find the device in by ID, then you would pass that to, or you would store that. Right here, I've got it on line 19. You're setting the video device ID to the one you found. But if you don't find it on line 24, then you're going to loop through and try by label. Again, I mean, it's a bit ugly. It doesn't feel clean, but it does seem to work. I mean, if your label is front camera, that's probably going to be the same for users most of the time. So failed to find it by ID, then you loop through. If you find it by label, then you on line 30 there, you can see I'm then using that device ID that I found that matched that label. And finally, if it doesn't find anything, it just takes the first device's device ID. That's a good thing to have in case somebody, say, has their USB camera set as their default, but then they unplug it. Well, you want to be able to default to something, some usable device. So that's sort of your detection algorithm. Try device ID, try device label, fall back to the first video device that you find. Once you've got your device ID, then you just make a standard call. So you can see on lines 41 through 48 there, that's the constraints I'm passing, and there's a specific syntax to be able to pass that video device ID in to say to WebRTC, get a stream, but get it from this specific video device. And then you pass those constraints to the get user media request on line 49. Once you get the stream back, then you do all the things you want to do with it, like send it to somebody else.
That's great.
Cool. Okay. So that's that problem. Next thing is, and this kind of harkens back to that interoperability problem I was talking about, where there's both variations in the way the spec is implemented, and then sometimes there's just holes. So one of the holes on Safari is they haven't implemented the sync ID stuff. And what that is the part of the API for media elements that allows you to select where audio is going to be sent out. So as an example, when this section right here on line 7 where it says, HTML media element, that's the content element. And the set sync ID is a method on that. And what that does is it allows you to say, if you have a specific audio output device, like say, my headphones here, or I might have another one like the speakers on my external monitor, you can say, I want you to output the audio through that specific device. So it's another thing that you can put in your app in terms of user selection. Say you let them pick their microphone, their camera, and this allows them to actually select the speaker that they want the sound to come out of. However, on Safari, they just haven't added support for that yet. So you have to be able to account for that. Meaning if your app has that feature to be able to set the speaker, you have to be able to detect when that feature just doesn't even exist and respond intelligently. So here's two different ways to do that. One is you can look for the set sync ID call on the HTML media element. That's the thing you call to actually set the sync ID. So that's one way to do the detection. And then on line 14, if you actually have the media element itself, you can just check for the sync ID property on it. And if it's not undefined, then you can go ahead and assume that you're going to be able to set that sync ID. This is one of the most brutal ones I've come into. So, and there's a very long WebKit issue post about this that talks about this limitation and all the discoveries that I've posted. A lot of things I've discovered about this particular limitation. And at the end of the day, the problem is if you make a get user media request and you've got your hands on an audio and video stream, and then somewhere, because your application is a little more complex, you make another get user media request. Say, for example, you're going to do another get user media request to get a different resolution or get data from a different camera or something. Well, on iOS, what that does is it kills the video stream from the first get user media request. It actually, technically, what it does is it sets the muted property on that video stream, and there's no way to programmatically unmute it. There isn't. It's like that is actually a non-editable property. So it creates this situation where if you're going to try to do anything complex with streams, you're really hamstrung on iOS, because anytime you use another get user media request, you're killing the first stream. So the most elegant workaround I found for this, let me scroll to the bottom here because it's, again, a backwards working up thing, is I grab a global stream right at the beginning of my application, like early on in the application lifecycle. I'll get that media stream of both audio and video, and then I'll use that global stream to copy and manipulate to get my hands on other streams that are useful to me to be able to do things. So this particular code example is showing where you can get one stream, and then from it you can create an audio-only stream and a video-only stream, say if you were sending those to different services for processing. So on line 38, I do my get user media request, and then in line 26, then that's the stream I've got, and that stream has an audio and a video track in it. And then I have some calls in here for make audio-only stream from existing stream and make a video-only stream. And we'll just look at the video only right here. So in that one, the stream that gets passed in on line 16 has an audio track and a video track. So what I'm doing is I'm using an WebRTC API that lets you clone a stream. Basically just makes an exact copy of that stream. It's not the same as calling get user media. It just gives you another copy to work with. And then with that copy, I'll use the get audio tracks thing, API call, to be able to pull the audio tracks, loop through, and then on line 20, use the remove track to take the audio tracks out of that clone stream I did. And what I'm left with is a new stream that only has the video tracks in it. So you can do the same thing in reverse for audio tracks.
Right.
So
so because it's performed this way, you don't need another auth.
Exactly. You don't do another get user media request. Correct. You don't auth again. You don't use a get user. Now there are limitations that wouldn't work with a second camera, for instance. But it does work when you're trying to do things with other streams, like maybe work with different resolutions, or send the video to one service and the audio to another, which I do. I'll send my video to my SFU, but my audio gets sent to FreeSWITCH to be mixed together there, because I like the audio processing in the mod conference a lot better than the audio processing in the SFU that I use. So it's a perfect example. This is almost verbatim the way I attack it in my code to be able to do my breakout groups. Audio goes to FreeSWITCH, the video goes to Janus to be distributed to the users.
Well, that's interesting.
Yeah, I mean, again, days of smashing my head to figure all this out. So my hope is in this 25 minutes, I save people 3 days worth of work. That's my whole goal. There's no need to go through the pain that I did if I can just tell you how to fix it, right?
Thank you for sharing this information.
Yeah, of course. So this is one that's so simple, but again, it was probably 2 or 3 days. It took me maybe a day to get it, because it was finding the problem. So Safari does not support the before unload event at all, or on iOS specifically. Sorry. So I need to put a little context around that. So the before unload event is a JavaScript event listener that you can attach that allows you to take actions before a browser page is going to be, say, before a browser tab is closed, or before the user closes the browser. So it's in the real-time media situation, a perfect example of when to use that is you would use that for like call cleanup, say to hang up your call to FreeSWITCH or to the SFU that you're using. Or even if you're going to reload the page, you might do that. In my application, there's a situation where if the user reloads, there's a portion of my media that I want to just hang up and then call back. So that wasn't working on iOS for me, and I had to dig around and eventually found out that before unload event listener isn't supported in iOS anymore. And there's a whole nother one they have called page hide. And so to get my application to work across all the different platforms, I have to detect which platform I'm on and then use the appropriate event listener. So that's what you see here in the example code. This thing on line 8 is the best thing I've found to reliably detect whether I'm on an iPad or an iPhone. I think it says there in the notes. I tried to do it just by detecting those properties on the window object, that they're all there. They just don't get fired. So that's not really helpful. So this line 8 just detects, am I on an iOS device? And if I am, then on line 9, I'm going to use the page hide event. And if I'm not, I'm going to use the before unload event that's supported in every major browser as far as I understand. And then from there, you attach your listener and you do your work. So hopefully if anybody is going to be dealing with call cleanup, especially on iOS, that's a nice thing to know to not get yourself into any trouble. Ken, I think that's all the screen share stuff I have. If you want to fire us back up to the regular conference screen. And I can take questions. I have a couple of links that while we're talking here, I'll just put into the chat, and I'm hoping they can go in to the to the About section in the video. So the first one that I'll put into the chat window here is a lot of this, almost all this, and maybe a little bit more, I talk about in an article that I wrote for WebRTC Hacks, the site run by Chad Hart. And that link is in the chat window now. So it's sort of written, if you really didn't write any of this down, you can go there and pretty much find all of what I just talked about there. It's a pretty complete write-up about it. Another nice place to go, because I certainly haven't talked about every problem I ran into, or you might run into other problems that I didn't, is the WebRTC issue queue. It seems to be the best supported place, Apple-wise, to be able to report problems and get some feedback. So that's a link that goes to the WebKit issue queue and filters specifically for WebRTC issues. You can find a lot of gold there. It helped me quite a bit, and I've posted quite a bit in there too. So also about stuff that I didn't talk about here. Radar's shit. Like you can't use it. I don't know. You posted it and then you don't even get feedback. So I can't even link to it. And then finally, just for interest's sake, let me just post this one more and then I'm done. That last one is a link to the more involved history of the evolution of WebRTC, if you're interested. Sorry, go ahead, Michael.
So do we have any questions from the audience? See. So I noticed that's the last link you provided was actually call stats.
Yes, from call stats.
Yeah.
Yep.
Okay, so somebody's come on.
Yeah, I saw the echo.
Yeah. Oh, it's me. Yeah, we had one question from Mark Diaz via YouTube, and he was asking. You were talking about the difference between SFU and MCU a little bit. Yes. And he was asking, what kind of additional hardware considerations are there on the MCU for all that mixing? And doesn't MCU really require, basically everything running on one server?
In the current version of FreeSWITCH, the current community version of FreeSWITCH, yes, everything has to be on one server. And I wouldn't even begin to pretend to offer official recommendations about the amount of firepower, but it can take a bit, especially if you're going to really be mixing lots and lots of feeds together. I'm trying to remember. I think that the example I offered earlier of 61 users that I had in at one time, I was running a 32-core machine, and it wasn't maxed, but it was getting pushed. But the 32-core machine handled 61 users comfortably. So that's, in terms of like some hard data, I can give you that. But it really is up to the environment you're using, how big the incoming video is. There's so many variables, it's hard to just give a pat answer to that. But it uses a lot of CPU. And if you're going to go the SFU route, you want to use a cloud provider or somebody who really doesn't care about bandwidth, because that can use a boatload of bandwidth. Because you're rebroadcasting, right? If 10 people in there and you're sending up a VGA signal, that same amount of bandwidth that you send up is getting sent out 9 different times to all the other people. So it uses a lot of bandwidth in the SFU scenario.
So follow up on that. I've actually, we've been running this conference here on FreeSWITCH for a while. This box is a Xeon with for threading enabled. And I think the most we've got on this is about 60. In mind, there's a lot of things that adjust there, like you mentioned, all the different video resolution, frame rate, what your output video resolution is. Are you doing things? And FreeSWITCH does some tricks to reduce the amount of processing power on the encoding side. Like, how many different ways do you have to encode it? Can you encode it all at one time in VP8 resolutions? Right. And all those things that address that. And then, Mark follows up, considering rapid improvements in bandwidth, including 5G around the corner, wouldn't it make sense to gear more toward SFU for the future and for scalability? And I kind of question that myself, because it's not just about the bandwidth. And when you're doing the SFU type thing, like what we're doing here, MCU, you're decoding one string. So yes, it's not just less bandwidth at the endpoint, it's also way less CPU. If you got, I'm looking at Michael and Chad right now. If I was doing this with an SFU, that would be 2 different streams I'm having to decode. Possibly, high resolution streams at high frame rate. So I could be chewing up the CPU on a mobile device or an iPad or a crappy Android phone.
Right.
It kind of really depends on what you're doing. If I could say anything after having worked with FreeSWITCH, and I think Chad would probably agree with me here, is set it up, test, come up with your own specific parameters, and test and see what you're actually going to get. And the FreeSWITCH team doesn't give performance numbers because changing one variable may change your performance levels and your load handling capabilities by literally an order of magnitude, if not more. So, test some more. And then when you think you've got it right, get ready for production. Then before you go in production, test again. Because you don't know, you really, there's just so many different variables along the way that, bypass media versus, transcoding. That's a huge, crazy difference in load handling capability. Mm-hmm. Yes. So,
can we run that test where it has like all the different video streams? Because I think that's like a really cool example.
That's a really cool example, and I wouldn't do it right now because we are actually double recording this once locally and once streaming it live out to YouTube. So that actually requires a fair bit of CPU power itself. But we are reaching the end of our time here. So Michael, Chad, is there any parting words you guys want to get in here before we wrap up?
Well, Chad, thank you for coming in today. Right?
Yeah, you're welcome.
It's always good to find these tips and tricks and all this, fancy stuff. And Ken, back to you.
All right, thanks guys. Again, Chad, thank you very much for coming out and joining us.
My pleasure. I'm happy to share so other people don't have to suffer like I did.
Yeah, Michael, thank you very much for talking with Chad today. We greatly appreciate that. Next week, guys, we've got some really cool stuff coming up. So be sure to come in here and join us for that. Check out all our old videos. You'll find some of these things, like Mark was asking today, have been addressed in different videos where we talk about scaling FreeSWITCH, where we talk about configuring FreeSWITCH and some of the other stuff. So you go back and check those out. For you guys that are watching on YouTube, if you have not done so already, click that little subscribe button right below here. And then there's a little bell that pops up. Go ahead and click that. You'll get notifications the next time we go live so you don't miss anything. You'll also get notifications when we post videos. So we'll post videos more than just ClueCon Weekly. So check those out. And we'll see you guys next week. Button.
You've been watching ClueCon Weekly. Tune in every Wednesday at 12 p.m. Central. Keep up with the latest happenings by subscribing to our YouTube channel, follow us on Facebook and Twitter, or visit us at FreeSWITCH.com.